What if your computer could be in two places at once? Seriously, forget the simple world of ones and zeros you learned about in school. The future of computing is about to get weird, bend the rules of reality, and solve problems we once thought were impossible. Get ready to have your mind blown as we dive into the quantum realm. Our current computers are incredible, no doubt. They've connected the world and put vast knowledge at our fingertips. But they're hitting a wall, a silicon ceiling. Everything they do boils down to a simple switch, on or off, 1 or 0. This binary system is powerful, but for some truly complex problems, it's like trying to paint a masterpiece with only black and white. Think about designing a new life-saving drug. You need to simulate how millions of atoms will interact. For a classical computer, that's an almost infinite puzzle. It would take longer than the age of the universe to solve. So, what's the answer? We need to enter the quantum realm. Instead of bits, quantum computers use qubits. A qubit is a game changer. Thanks to a wild principle called superposition, a qubit isn't just on or off. It can be on-off and every single value in between, all at the same time. Imagine spinning a coin. While it's in the air, it's both heads and tails simultaneously. That's superposition. But it gets even stranger. Qubits can be linked through entanglement, what Einstein famously called spooky action at a distance. When two qubits are entangled, they're connected no matter how far apart they are. If you measure one, you instantly know the state of the other. It's this combination of superposition and entanglement that gives quantum computers their almost unbelievable power. So, what can this power do? It unlocks the impossible. Take modern encryption, the security that protects your bank account and private messages. A classical computer would take trillions of years to crack it. A future quantum computer running something called Shor's algorithm could potentially do it in hours. Scary, right? But the same power can be used for good. Grover's algorithm could supercharge searching through massive databases, finding a needle in a haystack almost instantly. Most excitingly, quantum computers can perfectly simulate molecules. This means we could design revolutionary new medicines, create ultra-efficient batteries, and invent new materials we can't even imagine today, not in decades, but in days. Now, this all sounds like science fiction, and we're not quite there yet. Building a stable quantum computer is one of the hardest engineering challenges in human history. Tech giants like Google, IBM, and startups like Quantinuum are in a heated race. The biggest hurdles are things like decoherence, where the delicate quantum state collapses if it's disturbed by even the tiniest vibration or temperature change. So, when will you have a quantum laptop? Probably not for a very long time. But practical applications in research and industry are expected to start emerging within the next decade. We are standing on the brink of a new era. Beyond the hype, quantum computing promises to revolutionize artificial intelligence, creating AIs that can learn and reason in ways we can't currently fathom. It will transform finance by optimizing trading strategies and risk models. It will streamline global logistics, solving complex supply chain puzzles instantly. Of course, with great power comes great responsibility. We'll need to have serious conversations about the ethical implications, like the threat to our current digital security. The quantum revolution is happening right now, and it's going to reshape our world. Thanks so much for joining us on this journey into the quantum future. If you found this as fascinating as we do, make sure to hit that like button, subscribe, and ring the bell so you don't miss our next deep dive. Stay curious.